In this video, we're going to import a simple ROS URDF robot into XACRO. This will help us understand the workflow, the tools that we're going to use, the data that represents the robot in the different platforms, and how to navigate challenges that might come up during the conversion process. The most exciting part is this exercise will improve our understanding of the architecture behind NVIDIA Omniverse and explain why it's such a powerful tool for working with real-time digital twins. This all started for me a couple of years ago when I worked on the articulated robotics tutorial to set up a simple robot in ROS and using Gazebo to simulate that. I put a video online about that a long time ago, and you can see that it's running ROS and I've got my robot rolling around. I can actually control it here. And I set all this up in Docker to make it really easy for others to come in and set this up and spin the thing up really quickly. You can even find it on my GitHub page where I've got my first bot set up here, and you can actually come in here and clone this repo if you're interested in following along. We'll have all the files that we're going to work with in this description folder, and we'll go through the whole process of bringing this in. I've even got an article written for this particular video, and you can go to tech-multiverse.com to check that out if you're interested in a written walkthrough of this same process. Okay, so to get started, I've already cloned my repo locally and I'm in VS Code right now, and you can see if I navigate to my description folder, we've got our XACRO files, and I'm already set up in my terminal so that I'm already at that same description folder. And what we're going to do, since I don't have ROS currently installed, which is out of the scope of this video, let me just start up the environment that I've created where I have XACRO-doc installed, and you can see I'm basically, you can run the pip command to install it yourself. It's pip install XACRO-doc, and that's already there in this environment. I just like to keep my environments clean so I can destroy them and open up hard drive space. So what we're going to do, we're going to go ahead and copy this script, this little Python script that we're going to use to convert our XACRO files from these nested dev optimized files where you can see there's references. For example, this URDF file calls the others, the XACRO here, calling the robot core and the Gazebo controller. So these are all nested together, and we're going to flatten those into URDF using this script. Before we do that, we actually need to go into the Python terminal here. So let's start that up. And now we can just right click and say, go ahead and paste this as one line, since I've already copied this out, and put semicolons here to make this one line compatible. As soon as I hit enter, it will generate this new box robot URDF. And that's more or less just compiling all of these files into a single file that we can import into our XACRO now. So with that, let's move on over to XACRO. We're going to go ahead and make sure the extension is set up by going to Window, Extension, and searching for the URDF importer, and making sure that extension is enabled here, which we can see that. Then we want to go to File and Import, and we navigate to the description folder where we can see our box robot URDF that we created earlier. Now this is where the settings are for the import process, and these may be very important for your particular robot. I'm a little less concerned for my particular case. I know that some of the settings that I change cause the behavior to be different, and really I'm just looking for a basic import. So I'm going to set this up as a reference model. I have the USD output folder, which is where the USD files will be placed, and in this case they're going to be placed right next to our URDF file. We don't want static base for my robot because he's going to move around. If you had an arm, you might want static base. I'm not going to worry about density, and I don't really think any of these settings are going to apply very much to my robot. You can change the strength and the dampening if you want, but those settings didn't even come in for me. So we will set up collision from visuals and replace cylinders with capsules. and then we'll go ahead and hit import. And we'll accept this because it's just confirming that you're going to create the USD files in that location, which is the same place as our URDF. And once you hit yes, you might need to change your lighting. Stage lighting might make it so that you can't quite see it. And then you can click inside the viewport and zoom in, and there's your robot. At this point, I'd like you to focus on the content browser, where if you look inside there, we can see our box robot URDF that we imported and all of our XACRO files that were used to generate that. But now there is a box robot folder. If you click on that, you'll see that's where our USD file is. And next to that, you'll see a configuration file folder, which also has other USD files that this USD file references. But at this point, now we have our box robot between these two pieces here. We can bring them into any project we want. But for this particular project, we're just going to go ahead and keep moving forward. We're going to create a physics ground plane so that we can do a quick little simulation test. Let's go ahead and lift our robot up out of the ground a little bit. Get a proper angle here. And get this thing out from under the ground, basically. And what will happen here if we push the simulation play button, it's not going to do anything other than maybe just drop a fuzz of an inch down to the ground, basically. You're going to notice that the wheels are really rough and it doesn't go anywhere. That's okay, because what I want to explain is that what happens with the wheels is that my original ROS robot had a primitive cylinder in it, and when we imported that, it created a low poly tessellation mesh, which basically optimizes the visual side of this thing. And you can see what I'm talking about when you look at the left wheel. Inside the left wheel, you'll see visuals, which that's the wheel itself with a mesh inside there of a cylinder. But then you'll also see a collision mesh, which is the calculation that is used for the physics engine. So we're actually seeing a separation of the RTX engine and the physics engine within this left wheel. And the visuals side of this, if we were using a CAD or a high poly FBX that came from Blender or something, we wouldn't have the tessellated mesh, because those are automatically pre-tessellated. So it's just a better approach for what I'm doing. This is just a fun little project that I was just kind of learning from. But this was a valuable lesson to learn, that you can actually see the two different engines leveraging these components here, these prims. And these collision meshes are set up to run calculations at a much more efficient rate for the physics engine. And when you run a robot simulation with the visuals off, then you can now use that portion of the GPU for the calculations. So it's pretty neat. And that's really what's going on under the hood of Omniverse and why it's so good at handling the rendering of real-time digital twins that are rather intense files. Still takes lots of compute power, but it's cool to see that in action. So that said, let's go ahead and get this thing moving. Let's open up the joints and hit that left wheel joint and scroll down here. Got another whole video about joints if you're interested in seeing that. We will leave the target position, set the target velocity to 400, and then the dampening, we're going to go ahead and add that as 1,000, and that's going to mimic a motor so that this thing gets rolling. We don't want stiffness in this case, and now you can see our robot's doing a nice little circle. We'll click off of this so that you don't have that in the way. And that's pretty much it. That's really all we're going to do in this particular project, was just more or less get this thing imported. And you can see once the wheel goes away, it feels a little wobbly, but once the wheel's kind of hidden, you can see that the robot is actually quite stable. It's running, my mouse is not, but the robot's stable, as the collision mesh is the thing that's doing the calculation, determining where the robot hits the ground. Alright, so let's just wrap this up with a quick recap, where basically I've used my favorite little robot to do experiments with, and we were able to get him imported from my ROS project into Omniverse Isaac Sim. You can see the files that we created. We used the original XACRO files that we had, and then that created the robot URDF, and within that, once we imported that into Isaac Sim, it generated all the USD files that we have here. I think the tricky part of this is knowing what settings to use for your particular robot when you're doing the import and how that affects your robot. That is an area of experimentation and an area I have a lot to learn in. Now, a couple things that we did not cover is that we're not working with ROS directly in Isaac Sim yet, and we're not tackling controllers to where I can actually drive my robot with the, let's say, keyboard commands or anything. We'll worry about those in other videos. So thanks for watching, and we'll see you in the next video.